Hi folks, Mr. Long here. It's time for a screencast on how to graph square root functions. So what we're going to do is go through this process of graphing square root functions, and there's a couple different ways we can state it. Right, we've gone through what each of these letters mean in class, and so we know what A, P, and Q represent in terms of transformations, whether the A is a vertical scaling, the P and the Q are what are called translations or shifts. That's generally what we call them. And this plus and minus is a horizontal reflection. A also can cause a vertical reflection. Okay, so that's one way of saying it. Now, one of the things that we have to get used to is just seeing it as a general transformation. So instead of putting the function type, in this case square root, we just write the letter F. And what happens is everything that is, like right here, there's a square set of brackets, and here there's a square set of brackets. So I'll highlight those parts that actually would get square rooted. Okay, everything in the square brackets gets square rooted. So we're left with A and Q outside the function, right? That's why what's inside the function affects X, what's outside the function affects Y. Okay, so the function in this case is square root. Okay, so let's just quickly talk about the basic graph. The basic graph of square root, we know it looks like this. And every time we go over by 4, we go up by 2, right? 4, and then this is 2. Why is that? The square root of 4 is 2. Okay, what about a vertical reflection? So in a vertical reflection, we see that there's a negative outside the function, or the negative outside the square root. That makes all the y values that previously were positive become negative. And again, we see our 4 and our 2. Okay, what about a horizontal reflection? In this case, the negative goes inside. It's applied to x. X goes horizontal side to side, so it makes sense that it's a horizontal reflection. So normally, we would be at 4, 2. With a horizontal reflection, the x part becomes negative 4, 2. Now what if we reflect both x and y? Well, that means we have a negative here, that affects y, and a negative here, that affects x, and so it's reflected twice, horizontal followed by vertical. And remember that we read from the inside out. So I read the negative x first, then the square root, then the negative outside. Okay, so, and you're going to have a copy of this handout. So here's what we're going to do. These are the practice questions, but we're going to go through this example right here. So y equals the square root of, or negative square root of negative x minus 3 plus 5. Okay, and then this also could be written as y equals negative f square bracket negative round bracket x minus 3 plus 5. Okay, plus 5. So when we go ahead and do this, and where's f is square root. So first thing we want to do here, folks, is graph the straight line, plus and minus x minus p. So for us, that's going to be y equals negative x minus 3. Okay, and then we're going to graph the square root of negative x minus 3. How do we do that? Let's draw a rough sketch here. The straight line negative x minus 3, what does it look like? Well, I know the x-intercept is 3, and I know that it slopes down. Okay, I know that it slopes down and because of the negative sign right here. So now I can look, which way will the square root open? Well, I know for sure that these values here are negative, and I cannot take the square root of negatives. This value here, this y value here is 0. I can definitely take the square root of that, and in fact, I could take the square roots, any of the square roots going to the left. Okay, so that's the first part of that. That's the original function, so the line to the original square root. For that, we would see that it opens to the left because of the negative sloping line. So the next thing I need to do is, if you notice, when we look at this, it doesn't include the A or it doesn't include the Q. So I've done this. Now I need to do the A and the Q. So we remember that the A, in this case, is -1. And Q equals 5. So I'm pretty sure we know what's going to happen here. With an A of -1, it's going to be reflected vertically. Now what we can do is we're going to go back up and take a look at because it looks to me like both, there's a Y reflection there, a vertical reflection, and that's a horizontal reflection. So there's two reflections. So let's go back and look at what that picture looks like. Well, there it is there. So I know I go over by 4 and I go down 2, okay, unless the A value is different from 1. But in this case, since it's -1 for A, that means it's still going to be 4 over and 2 up or down. In this case, 2 down. Okay, so let's draw this. So I know that the X value of the cusp will be 3. Okay, and that comes from the 3 over here. The Q value will be 5 right there. And I also know that this graph will take on the shape where it's vertically reflected and horizontally reflected. So it will look like this. Okay, it will look like this, right from here to here. And then I'm going to notice that this is 4, this is 2. So what will this location be? Okay, so this one here is 3, 5. And so what will the new location be? Well, it's going to be, the X value is going to be 3, and then I went 4 to the left, so that's -4. And the Y value, so here it was 5, and now it'll come down by 2. Okay, it'll come down by 2. So what is that second point now? -1, 3. Okay, so those are our two key points. One at the cusp and one 4 units away from the cusp. And then the graph would keep going, right? Forever. All right, so what does the domain look like? The domain is this part of the graph, right? And it keeps going in this direction. So the domain seems to go from -infinity on the left to 3 on the right. Now, we can't touch -infinity square, so round bracket, then a square bracket at 3 because we can touch it. Now, what about the range? The range starts at y equals 5, and it seems to go on forever in that direction. Okay, so the lowest it goes is, again, -infinity, and the highest it will go is y equals 5. Round bracket, square bracket. Okay, folks, so that's how you do that. That's how you do a square root graph. Now, what we're going to do is just a really quick one. What happens if we get, we want to graph y equals 2 of root x plus, -1. Okay, this is going to be a second example. That should say B, actually. Here's our second example. So the first thing we always want to do, remember initially, we're just going to graph this part. So we're going to graph y equals x, and we're going to graph y equals the root of x. Okay, so this is going to be a really easy one to graph. Y equals x goes like so. The root of x will just be like that. Okay. And so what do we know in the next one? Well, in the next graph, I have to worry about a equaling 2, okay, the value before root x, and then the q value of -1. So an a value of 2 means that the y value is going to double. It's going to be twice as high. So when we go to graph it, okay, we know it'll be twice as high. So over 4, and instead of up 2, it'll be up 4. So first of all, let's locate our cusp. So last time the cusp was at 0, because we were doing the square root of x at x equals 0, and now it's going to be dropped down by 1 to -1. Okay, and we know that this one is not reflected in any way. So now what I'm going to do is it's going to go like this. Okay, so it's not reflected in any way. It just looks like the original function. Except now, when it goes over by 4, it goes up square root of 2, but we multiply by that a value of 2, and that's 4. Okay, so what will this ordered pair be? Well, it starts at 0, it moves to the right 4, so that's 4, and then it goes up by 4 from negative 1. Okay, from negative 1 up by 4, that's 3. What is the cusp? What is the ordered pair of the cusp? 0 and negative 1. Okay, folks, so the domain on this one would be from the left at 0 to the right at positive infinity, square bracket, round bracket, and the range starts at negative 1, the lowest y value is 1, the least y value is negative 1, the highest y value is positive infinity, square bracket, round bracket. Okay, folks, so those are some examples on how you graph the square root function.